That's HBV life cycle. Very briefly, the virus enters the host cell, and then the CCC DNA inside the nucleus transcribed into the HBV RNA. So at the very beginning, we thought about an early indicator of the activation of HBV CCC DNA. So we decided to focus on the HBV RNA. So it is known that CCC DNA is responsible for different types of HBV RNA. For example, um, the intermediate RNA, also subgenomic RNA, and then this RNA can be later on translated into the viral proteins for HBsAg, HBeAg, and other very important proteins of the HBV virus. In the clinical setting, we often collect the blood samples from the patients. So it means that we wish to identify some non-invasive biomarkers as an early indicator to monitor the therapy efficacy, also to see whether patients can achieve sustained biological responses. So how can we do that? At that time, we started this idea many years ago. So that was like in 2016. So at that time, our hospital took part in the national phase 3 clinical trial. So it's a randomized clinical trial with GSTs. So when we took part in that trial, we thought about perhaps we can discover some new ideas or biomarkers to see some new ideas. So in this clinical trial, we have two arms. One arm was treated with the interferon alpha 2A. Another one is interferon alpha 2B. And both of them are now approved by the government. So, but at that time, it was not clear whether two of them were like comparative. So in the end, we collected all the samples from the patients and then did the study because we wanted to focus on the HBV RNA. However, at that time, we read some publications about HBV RNA, but there was no company or no commercialized toolkits to measure the HBV RNA. So actually in our lab, we designed the whole protocol or the standardized toolkits to HBV RNA. So the first step to design the primers and the probes. So this is the results, and then we show that the primers were designed and conserved the weight. And then we also test the results in the lab. For example, the amplification curves to show our methods is very stable. Also, we performed many times to show that our methods can achieve 100% accuracy at the limit of detection, 250 copies ml. So, of course, several years later, now we improved these results even better. But at the time of submission, the best results we obtained at 250. So when we submit the paper, we decided that this one could be produce a very good results. So when we completed the design of the HBV RNA toolkit, And then later we want to show how can we really prove that HBV RNA is a possible biomarker to show the treatment response or biological responses. And then, so in our study, because there were so many clinical outcome definitions, and then we finally checked all the relevant publications, and then decided to use two popular treatment response definitions. Now, one is uh, serological response at week 72, and then the other one is HbSH loss at week 72. So at each time point, at the baseline, 12 weeks, 24 weeks, 48 weeks, and 7 weeks, we collected all the patient samples, and then we tested all the biomarkers. Uh, this is the results section. So first of all, of course, we presented the baseline results of our study. In total, we included 727 patients, and then this is the basic information. Um, so this is the major results because at baseline, 12 weeks, 24 weeks, 48 weeks, and 72 weeks, we tested four popular, let's say, for example, HBV DNA, HbSAg, HbEAg, and as well as HBV RNA. We can see the dynamic changes of the biomarkers, and they showed some differences. So what kind of differences? Of course, we use further changes to see how much changes for each variable, for each biomarker from the baseline level. So this is from the left figure A here. This is the result for the serological response. As we can see that HbSAg is the biomarker that does not change significantly. And then followed by HBV DNA. However, HBV RNA and HbEAg changed quite a lot. So we thought about that probably HBV RNA could be some useful early indicator. And then we also look at the HbSAg loss. However, we also noticed that the HbSAg loss in the patient sample, not many people achieved HbSAg loss at week 72. So in this case, probably we need a much larger sample size to support better results because the biomarkers do not distinguish significantly. And to compare the difference between the four six factors, we look at we use the predictor importance estimators of these biomarkers. And then from the left side, we can see the HbEAg seroconversion. So we look at, for example, HBV genotype, ALT, age, and other four known HBV biomarkers to see which one is more important than the other to predict the importance estimator. And then we found that actually HBV RNA is a very good one at the early time. For example, here we look at week 0 and week 12. So at week 12, it's the red circle here. It's the red circle from the left figure here. So here, if you can see the points, which is much more clear to the outside layer, it means that this variable is very good. So from the left side, we can see that the HBV RNA is a very good indicator. However, from the right figure, so it's a figure D here, we can see ACG is a better indicator, of course, because the outcome is HB ACG loss. So it makes sense. And then we comes back to the HBV RNA. Why? HBV RNA is a good indicator for the serological response, because HBsAg loss is HBV RNA does not perform very well in the prediction of HBsAg loss. So we only focus on the HBeAg seroconversion in these results. From the figure A here, we can see that actually HBV RNA at the baseline level, the AUC value, so it's a prediction power of the biomarker, it does not perform very well. It only achieves 0.63. But later on, when we look at the week 2, so it increased significantly in a very high level, 0.77. And then it becomes a little bit stable, even when we look at the time point of week 48. So at this time, we thought about that probably at week 12, HBV RNA is only sufficient to provide some clinical advices to suggest that the patient could continue the treatment or change to another treatment. And then, because in the clinical settings, we know that the patients usually have different, background factors or confounding factors. So we look at all the variables we have in the data set, and they performed the univariate and multivariate analysis to see what kind of key factors could be used in the early prediction. And then we found that 4 predictors, for example, age, genotypes, HBeAg, and HBRNA. These 4 variables are very significant, not only in the univariate analysis, but also in the multivariate analysis. And then in the clinical settings, we often wish that prediction accuracy could be very high. The higher, the better, right? If it is only like 0.77, that's probably not good enough. So we thought about if we can use multiple variables, and then our prediction power could be much better. So now we focus on what kind of these 4 key factors could be combined together to improve the prediction power. So that is the idea here. So from the A figure here, we plotted the AUC increase, because every time when you add a variable, you hope that the result could be better, right? So each time we add 1 variable to see whether it is significant changes. So from the right side, we can see that when we add more variables into the model, the prediction power can be much better, can be even more than 90%. Of course, the sample size becomes a little bit smaller. So how about the AUC performance? And when we combine all 4 variables together, the prediction power of AUC could be more than 0.8. And then in the end, in the clinical setting, that it's rather harder for doctors or patients to understand what is AUC and how they can apply. So in this case, we discuss with doctors, and then we use some statistical models to show that actually we can build up a decision tree. For example, we can look at the week 12, and then if the HBV RNA level is higher or lower than 1,000 copies ml. And then we look at the age and the genotype, and then HbEAg level, and then to show that whether the outcome at 72 could be like more than 80% or rather lower, and then make the decision at the early point to save money and the time. So in conclusion, our results suggest that HB RNA at week 12 could be a early early biomarker in the HbEAg positive patients, because our two arms in the clinical trial are treated by the interference. So we only limited our results into the interference settings. And then on the other hand, we suspected that HBV RNA, is transmitted, transcriptized from the HBV cccDNA. So it could be a early on-treatment predictor in this setting. The graphical highlights. So at the very beginning, we have a randomized clinical trial, arm 1 and arm 2. And then we collected all the data from the clinical setting. And then we identified HBV RNA plus other key and popular clinical biomarkers together. And then for doctors to improve their early predictions to show that the patients whether they can achieve HbEAg seroconversion or not. So this is the major results we have. And then after the publication, that was in submission in 2018-19, so it was like 4 or 5 years ago. After that, our team continued the research in the hepatology fields, and also due to the COVID pandemic, we also published several papers, and then some highly impact papers have been published in the recent 2 or 3 years. So this is our team from Second Shanghai Hospital, Central South University, and we wish to contribute more highly cited publications to the international Hepatology International, and we are grateful for this opportunity to give a talk here. Thank you.
Thank you very much. This is Dr. Omata. Sorry, because of the technical problem, I was late. But wonderful, Dr. Lee. Wonderful.
Thank you
because,
for your invitation.
I've been studying this RNA for almost 30 years, because the first paper we published is in 1985 on HBV RNA. So those days, those days, the question was how the RNA was packaged in the circulating virions, and then how it can be incorporated in the circulating virions. That was a very good, discussion about those days. But now it's a wonderful talk. So may I take some questions? George Lau, sorry about to be late.
No, not at all. I mean, so we have really expert panels here, and I can see Professor Ling Qing is here, and Professor Chen Peizhe is here, and also Percy from Europe is here. And I want to hear from them. Professor
May I have questions from Ling Qing? Especially you are concerned about the loss of HBsAg and specificity of this test.
Hi.
Because it's talking more. Yeah, all right, Ling Qing.
Yeah, thank you. Thank you very much for your invitation. Dr. Lee, I think this is a very impressive study. In fact, I have several questions in mind. So may I start with...
I will try my best.
Yeah, may I start with... when you do this study, I think your original design, I don't very completely understand your original design, because you are talking about randomized control study and to compare the 2A and 2B. So I'm not sure what's exactly the questions in your mind. And at the end, actually, when you analysis the results, you did not differentiate whether it's 2A or 2B, right? That's my number one question. My number two question is,
Can I finish answer the to
one
answer
by
the
one.
first
Yeah,
question
maybe.
sure,
Yes.
sure, yes,
Lin Qing,
please.
wait.
It's late, I may
You better wait.
forget.
Okay, sure.
Thank you.
Yes,
This is a very
Yes,
good
totally.
question.
Mm.
Actually, this is a question from one, if I remember well, it is one of the reviewers also asked this question. So we actually added in the supplementary, you know, the 2A and 2B result in the supplementary, because in the supplementary we have like 40 pages, and in this presentation I did not put there. So the conclusion is that there's no significant difference between the two groups because it's a inferiority design. Is that the right inferiority clinical trial? So it means that the two of them that do not show a significant difference.
All
Okay.
right. Is that okay?
Yes, yes, good.
And then second questions.
Should I continue?
Yes,
Yeah,
sure,
please.
sure, sure. Second one,
Okay,
please.
good. I would like to know your E0 conversion rate and your your model with two biomarkers seems promising in predicting the E engine zero conversion. So the question is this been validated in another cohort or it's only from this single study?
Validation.
Yeah.
Do-
So
do-
Yeah,
you're
validation in the
right,
different cohort.
right, different cohort, or you have split your cohort because you have a large cohort, or you
Yes,
have,
probably I should open the publication and then open the supplementary. This is also asked by the reviewer. So we actually added in the supplementary comparison results for ours with the other studies. Of course, we did not conduct another independent study, but here, let me see.
Then same result was obtained, basically in principle.
Yes, similar, except the HBV RNA. So this is summary of the the results here. As you can see, interferon alpha 2A.
33. So it's quite comparable with previous studies in terms about pegylated interferon treatment.
Yes, similar level.
Yeah.
But you know, the final ones, I think in the real world, we are not using interferon anymore, especially in Japan.
Yes,
So
that
next
is a
step.
very good question.
Yeah, what's the next step for you?
Well, it is a very good question. Interferon was approved in China. So in our hospital, some patients still receive this treatment. Of course, nucleoside inhibitors are now very popular. Some we tried to conduct another study to, for example, for patients treated with nucleoside inhibitors. However, we also noticed many publications have been published. So we do not want to be, to repeat other people's work.
Yeah, next step is predictor for the HBsAg loss and measures.
That's
and
possible. That's
I
very
hope you
good.
do the best.
But the
See you in
rate
Kyoto. I'll
more-
see you in Kyoto. I hopefully, you know, the APASL 2024 is in Kyoto, March, the end of March. You know that?
I know that.
Yeah.
I will tell
Did
my
you
boss.
submit the abstracts for that?
And haven't yet.
Yeah, please. Okay. Thank you very much.
Thank
George,
you.
any comments? George Lau.
Oh, well, I think that pegylated interferon should not be out of picture. Well, I work for pegylated interferon, and I'm glad to see this comparator studies. And I would like to bring in Professor Fusen Wang is here. Professor Wang, because he has recent observations on the pediatrics groups, who responds. Is Professor Fusen 在吗? Yeah, he told me he is online. Well, anyway, if that is the case, Professor Lin Qing also did very good work on those nuke-treated chronic hepatitis B patients with an add-on pegylated interferons and the
Right.
low surface antigens, they have a very high rate of surface antigen loss. That's a functional cure. But as I said in the opening remarks, surface antigen loss needs to be durable. And the new therapies we are looking into apparently inducing so-called surface antigen loss with a different significance. And I like to hear from the panel, so what do they think? Maybe Professor Jia is here.
Fortunately, I'm on the high-speed train. I hope you can hear me. Can you hear me? Can you hear me? Dr. Lau?
Yes.
Yeah. Jia, yes.
Yeah.
We can
Yes.
hear you.
Yeah, the connection not very stable here, but I clearly heard the presentation. It's really excellent work, and I don't have much new comments, but just congratulations, and I hope in the future you can have more work on the prediction of surface antigen loss, maybe in some so-called highly selected patients, or we call favorable profiles. Thank you.
Thank you, Jidong. We may close. We have to. Thank you very much, Dr. Lee. Wonderful. Great.
So we will have
Happy New Year.
Happy
New Year. Yes.
We had friendly discussions and more casual, but we have serious people in the panel. And I think that we should go for our next paper. Is Professor Yi here? Ready for or the Percy? Oh, Percy is here. Hi, Percy. Percy, you raise your hand. So you want to make a few comments before we go on?
Yeah.
Yes, please.
Hi, George. Many
Yes.
thanks for inviting me here. And again, congratulations to the excellent results. Professor Lee, I have a question, please. Because we know when you apply type 1 interferon, it may have at least two different activities. It may directly act on hepatocytes to get rid or to have an antiviral effect and get rid of cccDNA. But it may also affect the immune response against the virus. You mainly showed us viral parameters at the moment. Did you consider actually also looking at host parameters, virus-specific T cells, or other parameters of ongoing antiviral immunity?
That is a very, very good question. At that time, we thought about a different, ideas, but we have limited funding resources to conduct the T cells and the immune cells. And HBV RNA is actually supported or co-cooperated a local company. So that is why we have the funding to pay more than $500,000 to conduct all the process for the immune cells. And we hope to do that in the future. Thank you.
That would be fantastic. And perhaps we can use this forum to encourage funders actually to help you do this, because having access to this patient population may enable you to actually make very important discoveries here. We should not forget that oncology has profited tremendously from engaging anti-cancer immunity by using checkpoint inhibition. But checkpoint inhibition doesn't particularly work well in treatment of patients with chronic hepatitis B, probably for reasons that are related to the unique pathophysiology of chronic hepatitis B. But the only way of knowing why this is studying it in patients. So therefore, it would be great if you get more money, then include also more immunological studies in your next clinical
I will
study.
share your idea with my boss right after the presentation. And he will be very happy. Thank you.
Excellent. I think that maybe collaborations with expertise like Percy would be helpful. The immunological aspects need to be understood. Just hitting on one end with the new therapies. In fact, personally, I think that it's not adequate. It's a very complicated life cycle, HPVs and viral host balance. And if we want to move on with our therapy to benefit patients. First of all, we need to understand which patient should be treated with what and for how long. And before we embark, well, I'm not against new therapy developments, but they have to make sense with surface antigen loss, which is not that durable. So we are looking at different issues. And it's important we have a more comprehensive understandings with all the specimens collected from clinical trials and carefully studied. As Professor Professor Chen wants to raise a comment. Professor Chen is the new awardee for the Okuda NAM lectures at APDW, just conducted in Bangkok. So Professor Chen, want to raise the questions? You can.
I just a very short comment. Dr. Lee has done a good job, but in the future, pegylated interferon is properly used in the hepatitis delta. So in your population, I know the prevalence is low, but you probably want to study this. This maybe give more value for your investigation. I just wonder any case in your series.
Yeah, we have.
How many of them are positive for data?
Right now I don't have the data right now, but I will right after the presentation I will ask my boss from the hospital, and then they will collect the data, maybe start a new project, and we wish to have more collaborations with you and also other members.
Sure.
Thank you.
Thank you.
Good. Everybody wants to like to work with Professor Chen and also Percy. Should we move on to Professor Omata at this point to our next paper? Yes.
Sure, of course.
Yes, our next presenter is here, Professor Yi, to talk about precise fibrosis stagings. We'll share with the elastography in chronic hepatitis B. Professor Yi, are you here? Professor Wang is back. Maybe, we have been looking.
Hello, George. Just a moment ago, I was outside of this group, so I cannot speak. I would like to say Dr. Lee have a wonderful presentation, and I would like to say hello to you, Dr. George, and Dr. Lee, and Dr. Omata, or Dr. Chi Dongjia, and everybody. I would like to say Happy New Year for everybody. Actually, I'm wondering what Dr. Lee talked about the HPV RNA, whether this kind of biomarker can be used in children with chronic hepatitis B when they receive antiviral therapy, because the younger children with chronic hepatitis B have a high rate of functional cure. Can I show just 2 slides?
Yes, please.
Oh, yeah, sure. Sure.
Yeah, please, help me to just 2 slides. These 2 slides just in 2 manuscripts received by Hepatology International. And would you please, this is not mine, and then please, can I share my slides?
Oh, yeah,
please,
yeah.
Dr. Lee, you exit the share.
Okay. Let me see. Okay, close.
Yeah. This slide just show us, we can see, okay. We can see this slide in children, because I would like to show this slide. This has been, manuscript has been accepted by International Hepatology International recently. We can see we divided all the 372 children in 4 groups, 1, 2, 3, and 3 years old, and more than 3 years old to 7, and more than 7 years old to 12, and more than 12 years to 16. The cure rate is gradually reduced. And then at this group, just 1.6%, almost, but a little bit better than adult patient with chronic hepatitis B. All these patients just received 2 years of antiviral treatment. So we summarized the younger children, the higher rate of functional cure. And then why? We analyze 3 aspects. One is virology. The second is immunology. The third is the hepatocyte proliferation. The third is antiviral therapy. I would like to see a few one sentences to summarize what I want to see. For example, if an infant, the liver is very small, is like if they are 1 year old, the liver is only 10% of the adult liver, the volume. For example, at this time, when they receive antiviral therapy, there is a full viral suppression, and then new proliferated hepatocyte cannot be infected by this virus. At this time, the antiviral therapy, especially the adaptive antiviral therapy against HPV, is very good. It's not as expected by our before. Maybe several years ago, we didn't think the infant children, when they're infected with HPV, they cannot produce a strong adaptive immune response, but actually they can. So this is probably why the young pediatric children with the active hepatitis B infection, HPV infection, when they receive antiviral therapy, they can exhibit a high rate of functional cure. So I'm interested whether the HPV RNA can be used as a marker in a cured patient, like in this group. Thank you. That's all. Thank you, John.
So what type of therapy was delivered to these patients?
Well, very common, the nukes and interferon.
Nukes and interferon.
Yes, they are right now. All the drugs like nukes and interferon as used in adults. No special antiviral therapy.
Okay.
Tenofovir?
Pardon?
Tenofovir, TDF.
Oh, yeah. Oh, yes.
Okay. All right. Any further comments from the floor, the panelists? We have quite a few people here. Okay, if not, then we need to move on to, because of the time concern, we need to move on to our next speakers. And Ishumi, could you please put the pre-recorded videos to share?
Hello, Professor Page.
Yes, Ishumi.
Yeah.
The pre-recorded videos for our next presentation, Professor Yi.
Yes, now we are trying to. So would you please wait a moment?
長いね。
So he has sent you the pre-recorded videos, Professor Yi.
Is it possible to email to the secretariat?
Have you received this? No?
No, sir, in the email.
Maybe I just indicated that I heard that one of the speaker maybe upload a video, to present the work. but I don't know what is the next one or the other.
While we are waiting, just to say hello to everyone. I'm in a flight and I can see some of my very dear friends.
Professor Sarin. Hello,
Yes,
Professor Sarin.
Yes.
You are
I'm in a
also on a train, seems, or on car.
Yes, but it's nice to see everyone. And thank you. May please continue just to say hello.
Hi, Professor Sarin. Good to see you.
Yes, yes, and best wishes for the new year to everyone, their departments and families. Thank you.
Thank you very much. We are trying to connect to the Professor Yi's lecture. 你 send 到未 ？share 咗啦。咁而家未乜都冇。你 share 咗邊度？
While waiting, I must compliment George for his continued efforts, and I hope that 2024 we will have more of hepatology international contributions. Each one of you is an amazing researcher. So please enrich your journal, quote it everywhere where you go, and have a better impact factor for your journal. And thank you, George. Thanks.
You're always welcome. So you are simply on the flight. So this is a real background. I can see people are moving around. We are trying to technically we have problems now to upload and they didn't send to Ishumi for the link.
I'm on a high-speed train. The connection is poor, maybe disrupted. I'm sorry for this, but I'm still very happy to see all you all.
Sorry to keep you waiting. Now we got, so please, from now we show it. Thank you very much for waiting.
Dear professors and editors, thank you for your introduction. I'm Jun Zhaoye, and on behalf of the author team of Professor Bihui Zhong and Wang Wei, our team was majored in liver disease and metabolic dysfunction associated status disease. It's my honor to be here to give a brief presentation of our study of precise fibrostaging with shear-rate elastography in chronic hepatitis B depend on liver inflammation and status. As we know, fibrostaging has been acknowledged as a hallmark of disease progression in chronic hepatitis B. Underestimation may delay antiviral therapy and worsen liver damages, while the overestimation of fibrostage may lead to treatment of uncertain benefits and increase the healthcare burden. The gold standard as liver biopsy is limited by its invasive procedure. As the latest generation ultrasonography elastography, two-dimensional shear-rate elastography, named as 2D SWE or SWE in this study, it possesses higher reproducibility, accuracy, and the full advantage over transient elastography and the point SWE, such as it can make a real-time visualization of the fibers distribution and accretion time within a few milliseconds, which minimize the interruptions from patient or the operator movement. And you have a larger detection region, which is up to 700 millimeters square, and its generation of a shear wave directly from the tissue, enabling reliable liver stiffness measurements from patients with ascites or obesity. All of these improvements were devised to obtain liver stiffness measurements that were more indicative of the fibrosis severity. However, the confounding factors of SWE require validation. The ideal situation for a patient without confounders can be accurately estimated and recommend whether they should receive liver biopsies. In this study, we aim to investigate the factors that are linked to the diagnosis performance of SWE in patients with chronic hepatitis B. Furthermore, we integrate these factors to predict the accuracy of SWE for fibro staging, which may improve risk stratification for patients who might benefit from liver biopsies. We conduct a prospective study registered in the Chinese clinical trial. We enrolled chronic hepatitis B patients with and without non-alcoholic fatty liver disease in the first affiliated hospital in the Sun Yat-sen University from the February 2015 to December 2018. We have collected the anthropometric parameters, including body mass index, waist circumference. The 2D SWE for liver elasticity detection was performed by the Professor Wang Wei, and he is the same operator, and he used the same transducer. A rectangular electronic region of inches, approximately 4 plus 3 and 3 meters, and a set of 1 to 2 kilometers under the liver surface was displayed on the best SW image, in which a circular region of inches with a diameter set about 2 cm was set for analysis. Liver biopsies with histology examination using Mantoux staging criteria, manganese resonance imaging derived proton density fraction, MRI-PDFF assessment for the ultrasonography status. Liver fibrous markers and liver injury markers, including ALT, GGT levels, were also measured. Hepatitis B related markers and metabolic indicators were also detected. Overall, 414 patients were in the final analysis. The majority of 70% patients were male, and the mean age was 44 years old. For the 85 patients with biopsy-proven liver status, 76 patients, which is 89%, were detected with abdominal ultrasound, and all were confirmed by MRI-PDFF. Notably, the area under the curve achieved to nearly 90% for all liver fibro stages. There was no significant mean liver stiffness measurements value between those with or without ascites, nor patient with or without recent variable bleeding. However, the diagnostic discordance rate of fibro staging was 26%, while 10% patients has a discordance of over 2 stages. The majority, about 56% of discordance, were attributed to overstaging with SWE, and the remainder, about 43%, were attributed to understaging. For discordance, multivariate logistic regression analysis identified that the status degree, which we determined as moderate to severe status, as an independent factor. With respect to underestimation, moderate to severe status and GGT levels remained significantly after multivariate analysis, while mild status and the ALT levels over 5 times above the upper of the limit were found to predict the overestimation of the fibrous stage by SWE. In patients with ultrasonography status, the liver stiffness measurement values were highest for fibrous stage of 0 to 1. By comparing the liver stiffness measurement of SWE of different histological inflammation activities in the same fibrous stage, the subjects with inflammation activities over 2 had a higher mean liver stiffness measurement of SWE than those grouped in the fibrous stage 2, while no difference was observed in the other fibrous stages. The performance of SWE for the diagnosis of significant and severe fibrosis was significantly better in non-status case than in patients with status by comparison of areas under curves. After quantifying ultrasonography status with MRI-PDFF, mild status and moderate to severe status patients had higher rates of misstagings, which is 35% and 58% versus 21%. And similar trends was also observed in the overstaging, 21% versus 32% versus 8.3%, but no in the understagings than patients without status. The performance of SWE for the diagnosis of significant and severe fibers was significantly better in non-status cases than in patients with status by comparison of area under curves. In patients with inflammation activities over 2, lower area under curves for fibrous stage over 2, and the higher percentage of SWE misstaging, overstaging, and understaging were observed compared with those with inflammatory activities as 0 or 1. For identifying fibrous misstaging with SWE, we built a new model based on the impetus that was significantly related to the discordance between SWE basis and the pathology fibrous stage using logistic regression. The compiled prediction formula with the optimal series value was with 76.5 sensitivity and 83.7% specificity. In patients with biopsy-proven fibrosis, the area under curves was 82% with sensitivity of 64% and the specificity achieved to 94%. With 500 types of footstrat resembling, calibration curves presented visually good agreement between the predicted model and the actual probabilities. Over 82% of patients with chronic hepatitis B could benefit from this model, and therefore correctly make a diagnosis of fibrous staging with SWE and avoid liver biopsies. And we also established a workflow and a confounder-based model for SWE management of fibrous staging in chronic hepatitis B. If a patient with a chronic hepatitis B, we firstly perform SWE assessment as well as several markers of GGT and ALT levels. And we also acquire its status severity by the ultrasound. If moderate or severe status was detected, we conducted further MRI-PDFF quantification of liver fat contents. And we will put all this information in our model to calculate a risk estimation of SWE misstaging. Those with high-risk misstaging would be informed to receive liver biopsy. In conclusion, this study, status and inflammation were identified as independent predictors of SWE inaccuracy. Combining these factors demonstrated high diagnosis accuracy for predicting correct SWE staging, which may assist in selecting candidates for liver biopsies after SWE assessments. Thank you for your attention.
Well, this is a pretty interesting publications for the non-invasive assessments of liver fibrosis, which is pretty important, especially it mentioned about the importance of steatosis, which might affect the assessment. I think we have the two papers presented, and anything that the panel would like to discuss on behalf of APASL Viral Elimination Task Force, and comments of how we are going to move forward to benefit our patients. So may I ask anyone would like to make a comment on the...
Yeah, George?
Yes.
You don't.
You are here.
And got out. The train delayed, so I still on the train. Wow, the excellent talk. I just have very short question and comment. This is excellent work on the study try to delineate the factors influencing the liver stiffness, which is very, very sophisticated. So my question, how do you apply this kind of characteristics, the factors in clinical practice? Because the value is very simple, but we understand the steatosis and neck inflammation would influence the steatosis. How do you easily or simply use in clinical practice? Thank you.
Well, this is a very good question, but the speakers is not online, so I'm not in a position to answer your question.
I'm sorry. I'm sorry. It's a video. I'm sorry.
It's a video.
Video talk. I forgot.
In fact, Professor Jia, you are the world experts in this area. Why don't you bring out what you are thinking? What is your thought?
Well, that's already, we very simple thing is, of course, we try to avoid use this liver stiffness in patients with high ALT, 5-fold higher than normal. That's one thing, of course. But maybe later we can have some simple way to try to normalize the value. Maybe use an APP calculator, something that helps the doctors very quickly to figure out. That's just the very preliminary thinking. I will know. Well, maybe in the future we can try that. Thank you.
Well, I think that the data is important. Understanding from the literature, good studies needs quality data, and we are going into the age of artificial intelligence and the big data collections. Maybe we can work out the algorithms, in my opinion, how we are going to tackle the problems and to more precisely define the degree of liver fibrosis, which is a very important prognostic factor for chronic liver diseases in our patients. We simply need good quality data, and China is a driver. We have a lot of hepatitis B patients, and with a lot of experts like you yourself, Professor Jidong Jia, and Professor Lin Qing and Professor Fusen Wang, and also Zhang Xingxing from Shanghai, and so on. So with the collective efforts in connection with the context of APASL Viral Elimination Task Force, with the leadership of Professor Martin and Professor Sarin, we look forward to have a forum discussions and ongoing understanding and collaborations. And I think this is a key to play. And Professor Yuming Long is also here, and Professor PJ Pager is also here. Maybe we can hear from Professor Yuming Long. You want to make a few comments from Kaohsiung? Yes. Professor Yu.
Yes, thank you, George. I think it's a quite very interesting and important study, especially in the clinical practice. But current, I would like to say that the algorithm for the so-called in the high misdiagnosis population, maybe right now we can test whether the use of FibroScan, because it also can counting the steatosis degree more easily when compared to the MRI PDFF. So I think for the to expand or to apply this algorithm for the clinical practice, maybe the authors can extend his study, try to use the more convenient non-invasive methods such as FibroScan. To see whether it also can easy to apply for this algorithm. That's my comment.
I cannot agree with you more. May I have maybe Professor Professor Jiang is from Shanghai. Maybe we can Professor Gao. You want to make a comment? You are the experts in fatty liver.
Okay, thanks, Professor Miao. I think it's very important to diagnose the fibrosis stages according to the etiology of liver disease and the background of the degree of steatosis and inflammation. However, it's difficult to take conclusions which is the best choice for diagnosis of liver fibrosis. I'm no idea which is the best, maybe FibroScan, FibroTouch, or any other index. Maybe MRE is a good tools for diagnosis of fibrosis, and we need more data.
George, may I comment, Dr. Omata? Thank you.
Yes, please, Professor. Yes, please.
My clinic is based upon the degree of fibrosis fatty changes. And recently, more than 3,000 cases I observed. If you have more fatty changes, maybe the fatty changes suppressing the development cancers because it's clearly correlated with the fibrosis degrees, obvious. Advanced fibrosis, more cancers. But if you divide those with advanced fibrosis depending on presence or absence of fatty changes, strangely enough, more fatty change group has less incidence of cancer, observing 3,000 cases for the 10 years. So I think people are saying it's a burnout, but if you have to show, I think we have a difficulty to burnout phenomena is a real or not. In other words, if you lose the fatty change, you may have a progressive fibrosis. But quite contrast, I think maybe fatty change is suppressing the cancers. That's my clinic after you see 3 years. That's the real world data. So I think the future discussion should be focused upon presence of fatty change and the presence of the advanced fibrosis. I mean, two may be, contradicting. So that's my clinics. Just a comment. I want to have your opinion.
Yeah, interesting observation.
Yes.
Interesting.
Yes, yes. Thank you, Professor Omada. I also have the same observation, especially when if the patient just have simple steatosis, have no metabolic dysfunction. Sometimes somehow we look at it's a protective effect for the long-term complications. Only for patients with fatty liver and metabolic dysfunction, they are at higher risk of the long-term complication. So that I also observed this clinical cohort. Quite interesting.
Yeah, tonight I cannot show myself, sorry, but I can show myself in Kyoto for sure. So we can.
Something wrong with you, Professor Martin?
Yes, I'm sorry. I mean, technical problems.
Okay. Well, I think we have interesting discussions with a very good panel, and I really enjoy the team spirits over here. After working together with all of you in Asia Pacific regions, we are entangling with different socio-economic issues, sometimes political issues, but then we always come back to our patients despite all the difficulties. And I would like to see whether any panel members want to make a comment before we close the sessions, because we have come to.
Why don't you invite Hasmik?
Yes, yes, Hasmik. Hasmik from Armenia.
Yeah. Or Nekati or Meji. How are you?
Yes, yes, Hasmik.
On everyone, I have no any comment. I would like to say only and Merry Christmas for everyone.
Merry
Thank you.
Christmas. Happy New Year.
And Odavi is here.
Yes.
May I have?
Yes, please.
I wish everyone Happy New Year first, and then I would like to mention that the fibrosis degrees are changing between the hepatitis B, hepatitis delta, hepatitis C, and other diseases. For example, I had several cases about multiple myeloma, and those cases had more than 75 kilopascal. So I think we have a little bit problems to real fibrosis degree to decide. I just noticed that.
Dr. Hamid, Saeed Hamid. Dr. Hamid.
And maybe Dr. Odov from Mongolia. He is here. Our Mongolian, the dean of the Mongolian Medical School.
Odov.
Padahu.
Sorry, I just say goodbye. I just say goodbye to you.
All
I arrive.
All right, okay. See you soon.
Dr. Yu, me, you, Emily.
Hi.
Okay.
Hi, Professor.
Next
Happy
year.
New Year.
I will see you next year.
All right, George.
Okay.
In Kyoto.
Okay. All right. See you everybody in Kyoto.
Happy New Year, everyone.
Thank you.
Bye-bye.
Thank you. Bye-bye.
Bye-bye.
Bye-bye.